Have you ever just stopped and wondered how your phone or your laptop can do all this incredible stuff? I mean, streaming movies, connecting you with people across the globe, it feels like straight up magic. But the secret behind it all is actually surprisingly simple. And today, we're going to pull back the curtain and look at the fundamental building blocks of every single digital device you own.
So here's the big puzzle, right? At their very core, computers are incredibly basic. They can only recognize two states. An electrical signal is either on or it's off. That is it. So how do we get from that simple little switch to, editing video, playing a massive online game, or calculating a rocket's trajectory? How does on and off become, well, everything else?
And here's the answer, and it's kind of wild. It's not one big, complicated thought process. Nope. It's billions of incredibly small, incredibly fast decisions being made every single second. Every single thing your computer does is just the result of breaking down a huge problem into a long series of tiny, simple questions that only have a yes or no answer.
Now, to make all of these decisions, computers need a language. But it's not a language of words like English or Spanish. It's a language of pure logic. It's got very strict rules, and it is the foundation for how every digital circuit in the world processes information. That language is called Boolean algebra. Now, look, don't let the word algebra scare you off. It's not what you're thinking. All it really means is that we have a system where every single statement, every value, can only be one of two things. It's either true or it's false. There are no maybes, no sort ofs. It's black and white, simple as that. So in this super simple language, we basically only have two words. We represent true, or an electrical circuit that's on, with the number 1. And we represent false, or a circuit that's off, with the number 0. And that's it. That's the entire vocabulary. Everything a computer thinks, says, or does is built from just those two little numbers. Okay, so if Boolean algebra is the language, then who's doing the talking? Well, let's meet the physical decision makers. These are called logic gates, and they're the teeny tiny electronic circuits that are actually performing these logical operations inside every single microchip. All right, first up, we've got the AND gate. This one is the strict one. Think of it like a bouncer at a club who needs to see both your ticket and your ID. If you only have one of them, sorry, you're not getting in. The AND gate only outputs a 1, or true, if every single one of its inputs is also a 1. This little chart here is called a truth table, and it basically shows you the rules in action. As you can see, if input A is off and B is off, the output is off. If one is on, but the other is off, the output is still off. The only way we get a 1 on the output is if input A and input B are both 1. See? Strict. Okay, so next, meet the OR gate. This one is way more flexible. Think of a coffee shop that takes cash or credit card. As long as you have at least one of those, you're getting your coffee. The OR gate works exactly the same way. It'll output a 1 if input A is 1, or if input B is 1, or, hey, even if both of them are 1. And you can see the difference right here in its truth table. The only way to get a 0 of false is if both inputs are 0. Any other combination where at least one of the inputs is a 1, you're going to get a 1 at the output. Much more lenient than that tough AND gate, right? So here's the bottom line. AND is all about all. All conditions have to be true. OR is all about any. Just one condition needs to be true. These two simple decision makers are the foundation for a huge amount of the logic inside our devices. Finally, there's the simplest and, maybe the most essential gate of them all, the NOT gate. People often call it the inverter because, well, that's literally all it does. It takes one input and just flips it to its opposite. It's the ultimate contrarian of the circuit world. And yeah, its truth table is about as simple as you can get. You put a 0 in, you get a 1 out. You put a 1 in, you get a 0 out. That's the whole story. But this simple ability to just flip a signal turns out to be incredibly powerful. Okay, now this is where the real magic starts to happen. These gates, AND, OR, and NOT, they're like digital Lego bricks. By themselves, they're pretty simple, but when you start snapping them together, you can build almost anything you can imagine. Let's see how. So, for example, what happens if we take the output from our strict AND gate and feed it directly into a NOT gate? Well, we've just created a brand new gate, a NAND gate, which just means not AND. It does the exact opposite of an AND gate.
And this process of combining basic gates is how everything gets built. You string a few more together, and you can make a circuit that adds two numbers. You combine thousands of those, and suddenly you've got a basic calculator. That's how we scale up from these simple little decisions to incredibly complex computations.
So, okay, why does all of this matter? We've gone from this abstract idea of true and false all the way down to these tiny little circuits. So let's zoom back out and connect these fundamental building blocks to the powerful gadgets we all use every single day. This is the part that just blows my mind. A single modern computer processor, like the one that's probably in your laptop right now, can have over 50 billion transistors. And every one of those transistors is part of a logic gate, making one of these simple logical decisions billions of times every single second. And what that means is that every single piece of digital technology is built on this foundation. The processor, the memory in your computer, every digital circuit, the smartphone in your pocket, they all operate on the exact same principles of Boolean logic and these simple little gates we just talked about. They're just doing it on a massive, massive scale. So when you boil it all down, it's kind of incredible, isn't it? The immense, almost magical complexity of our entire digital world is built from an incredibly simple set of rules, true or false, on or off. Which really leaves us with one final thought. If we've built all of this, all our modern technology, from just a few simple logic gates, what's the next big idea we can build from them? What future innovations are just waiting to be constructed from these same humble digital blocks?